Hi, and welcome to part 2 of multiple regression in R using OLS estimation specifically. We're going to pick up right where we left off in part 1. So you'll remember there that our main model that we were focused on, we called LM1 linear model 1, had one dependent variable y and 3 independent variables, all these x's. So we have unstandardized regression coefficients here, standard errors, t values, and p values. Only have one that we would traditionally call statistically significant x2 here. Down here, we have the r squared, so we're explaining about 12% of the variance in y. And then down here, we have the f statistic. So one typical thing that we want to do is test assumptions, and many of the assumptions of multiple regression revolve around the residuals. So a first thing we're going to do is just do a visual inspection. So once we run that line, we need to go down here actually and then click return a few times. And then you'll see down here in the right hand corner, we had a bunch of plots pop up, and we can actually scroll through these. Main one we could first look at, and this is specific to the normality assumptions, or that the residuals are normally distributed. Essentially, without going into detail, what you want to see is that all these little dots, all these residuals, follow this diagonal line pretty closely. So that's what it looks like here for us. So visual inspection looks pretty good. So next, we're going to install another package. Of course, if you need to, if you don't have it already, ggplot2. Really, the plot we're going to do here is, not super necessary, but I just want to bring it up. ggplot2 is a very popular tool for plotting and kind of customizing your own plot. So it's a nice package to have. So here I'm plotting the residuals basically as a histogram. Again, to reiterate, you'll see that how I did this here, the LM1 right in that box, I'm specifying I want the residuals, specifically plotting the residuals. And this is the data again. So basically, we want to see if this mostly looks like a normal curve, again, when we're focused on the normality assumption. So just based on visual inspection here, that histogram, and then that QQ, it looks pretty good. But we can also formally test it. And then here we go again, installing more packages. If you don't have it already, this moments package. So we can look at skew and kurtosis values specifically. If it were a perfect normal distribution, skew would be 0 and kurtosis would be 3. And essentially, you can test that as your null hypothesis. Actually, I don't know how to pronounce the name, so we'll call it a JB test, and this is how you can do that right there with the residuals. And this is one of these times where we do want a relatively high p-value, because a null hypothesis is, not technically normality, but more or less in practical, that's how we interpret it, that it's a normal distribution. So we fail to reject that null hypothesis, which is a good thing. So that's one assumption down, and I provide some additional kind of details about that test and the specific reference as well. Next, we might want to look at the residual variance, basically seeing if it depends on other things. That's where we get heteroskedasticity, which is a tough word to pronounce. But that's basically the idea. The residuals, for example, might be related to an independent variable. And that's actually the basis of how we test for this. But first, you can do a visual inspection in a few ways. Some of these plots are all pretty relevant. But this is a basic one. We can look at residuals versus fitted. And basically what you want to see is consistency, kind of more like bars going across this middle line, or essentially you want this middle line to be kind of straight. We don't want to see something like a fan, like this line was kind of more diagonal. Something like that could be an issue. And that can be a result of something like having clustered data, which hopefully you would know that ahead of time. In later videos, we'll talk about how to address that. But that can be an issue, though there usually is a common reason for it, and usually you should know that ahead of time. We'll talk about some later things to address this stuff. But in terms of testing it, first, of course, installing more packages. The first one we're going to do, can't remember how to pronounce the name, so we'll call it just a BP test. I'm just going to run through this and then kind of explain what we just did. Then installing another package for another test here. So let's kind of let that all run for a second and then kind of explain what we just did, and then get to a little bit of an explanation of what's happening down here. But you can examine different types. So for example, that might be a linear relationship between one or more independent variables and the residuals. And that's what that BP test is doing. Essentially, it's taking the residuals from that model and using that as the dependent variable, and then regressing that onto our independent variables. That's basically the idea of it. And then the next test, which there was multiple versions, the white test, the one is just a bootstrap version. I'll explain bootstrapping a little bit later on, but just want to kind of show it here just so you can see it kind of just a different way of testing things. But that the white test is often referred to as a generic test. Here, the white test adds squared terms in case there's some sort of nonlinear relationship there. But notably, technically, the full white test includes everything in there. And that's where we get to this whole line down here. Even though we're doing the command of BP test, we're essentially just using the function to do the full white generic test. So basically here we're trying to capture all the different types of relationships that there could be between our independent variables and the residuals in our model. So you'll see here, really we're just adding things. So we already are adding the linear model one, and now we want to add additional things to it. So we're adding interactions between all the independent variables, and then we're also adding squared terms. So that'd be the full test. And for each of these tests, it's similar to the the JB test that we were just talking about for normality of residuals. We want high p-values specifically in this case, or generally, I guess that's what you'd want. Though maybe you're just kind of know it's probably going to be a violated assumption and just want to formally check it or formally show it in some way. So that's three different ways essentially of testing that. And again, I provide the papers on it, and it is a little weird. You have to do the full generic to get the full generic test, but most of the results will probably be pretty similar. If they're not, again, it might be an important indication of something. The other kind of basic assumption we look at would be independence. And this is one like several others that you should probably know ahead of time. For example, again, I've mentioned cluster data or nested data. That's going to violate the independence assumption, and often that can show up in kind of issues in your residuals, such as heteroskedasticity. But again, hopefully you would know about that ahead of time. In future videos, I'll talk more about approaches to addressing and modeling that. But for now, we'll just kind of note that those kind of three main assumptions, though technically there are more. Last thing that I just want to end the video with, and again, there are several different ways to get standardized coefficients, but that's relatively common that we often want standardized coefficients. And I'm just going to show one way, though we'll learn and do different ways in the future. Again, installing another package, again, kind of just getting in the hang of this. So here, now we're getting our unstandardized estimates, and now we're also getting the standardized, fully standardized regression coefficients. They're not that different, basically because this is simulated data that I generated, where they're all basically normal or almost z-scores. So they're not too different, but in the real world, that might be different. In the script file, I provide a bunch of other kind of information, other assumptions, kind of discussions around outliers, as well as collinearity and how you could possibly check that. But otherwise, that's the end of the focus on kind of the basic multiple regression. In future videos, we'll keep on learning other things, for example, like generalized linear models, checking out interactions, mediation, and then advance toward things like multi-level models and structural equation modeling. So I'm excited to keep the video series going, and I hope you enjoyed and got some value out of these current two videos.